In this video, we're going to review adding and subtracting with negative numbers. So let's take a look at some of the rules involved in adding and subtracting negative numbers. Adding a negative number can be changed to subtracting the same number. So here we have an example of adding a negative number, 5 plus negative 3. This can be rewritten or changed to 5 minus 3. And I think we would all recognize that the answer to 5 minus 3 is the number 2. So when you see a negative number being added, you can convert it to subtraction. Next rule is that subtracting a negative number can be changed to addition. That would look like this: 5 minus a negative 3. When we see a subtraction of a negative number, that can be changed to addition. So 5 minus negative 3 is just 5 plus 3. That looks way simpler, and we know that 5 plus 3 is 8. So that would be the simplification of that statement. Another rule that's worth keeping in mind when we are combining numbers involving negative numbers is that when the signs are the same, add the numbers and keep the sign. Let's look at this first example. Negative 5 plus a negative 3. The signs are the same. We would also consider the signs to be the same if we rewrote this as minus 5 minus 3. Signs are still the same. Both of these, we can consider these to be negative. So we add the 2. 5 plus 3 is 8, and we keep the negative sign. Here we have 12 plus 8. They're both positive. So we just add those together. Our answer is 20, and we leave it positive. Down here, minus 4, minus 9. There is a minus sign in front of both of those numbers. We add the two numbers. What I mean by that is we add the 4 and we add the 9, and we get 13. And then we make it negative because they were both negative. When the signs are different, what we do is subtract the numbers, and we use the sign of the larger number. So when we subtract, we're always going to use the larger of the two numbers. So here, minus 5 plus 3, these signs are different. This is the larger number. So we subtract the smaller number from the larger number. 5 minus 3 is 2. But we keep the sign of the larger number. So this becomes minus 2. Let's look at this next one. 12 plus negative 5. We could also rewrite this as 12 minus 5. But either way, we're going to treat the 12 as positive. The 5 is negative. They are different signs. So we subtract the smaller from the larger. 12 minus 5 is 7. And this was the larger number, and it is positive. So our answer is a positive 7. We can think of there being a plus sign there, but we don't write the plus sign. In this last one, 11 minus 9. So we're thinking of the 11 as positive, and the 9 is negative. 11 minus 9 is 2, and the larger number is positive. So that is a positive 2. Let me give you one more example. Let's say that we had 3 plus a negative 6. Now, in this case, the larger number is 6, and it's negative. So 6 minus 3 is 3, and the larger number is negative. So the way you can think of this is that the larger number is going to win the sign battle. Since the larger number is negative, the answer becomes negative. In this video, we're going to review multiplying and dividing with negative numbers. Just like adding and subtracting negative numbers, any negative number in an expression that you're trying to evaluate can make the problem quite a bit trickier. So the first rule we want to talk about is that multiplying or dividing any two negative numbers creates a positive number. Here's some examples. Two negative numbers being multiplied. We're not going to focus on what the answers to these are, but just whether it's positive or negative. Two negative numbers, that will be positive. Two negative numbers, positive. It doesn't matter how large they are, positive. And good news is that no difference for dividing. Negative 6 divided by negative 3 will be positive. These two numbers, negative 4 divided by negative 40 divided by negative 40, positive. Any two negative numbers that are being divided, one into the other, will be positive. Now, if there are an even number of negative numbers being multiplied or divided together, the result will be a positive number. A few more examples. That's one we just talked about. Two negative numbers being multiplied together, but four negative numbers being multiplied together because there are an even number of negatives. 1, 2, 3, 4 negatives. That will create a positive number. Even 6 negatives being multiplied together. That's probably not something that you would see, but just a demonstration that if there are an even number of negatives involved, either multiplying or dividing, the answer will be positive. Here we have an example involving division and multiplication, but we can see 1, 2, 3, 4 negatives. 4 is an even number. The result of this will be positive. Once again, we count the number of negatives. 1, 2, 3, 4. 4 is an even number. The result will be positive. All of those negatives will end up canceling each other out. If there are an odd number of negative numbers, that's going to create a negative number. That's probably not a big surprise. Here's an example. We have 1, 2, 3 negatives. The answer to this will be a negative number. Two negatives will cancel, leaving one negative. Here we have 1, 2, 3, 4, 5 negatives. 5 is an odd number. The result of this will be negative. This is a pretty extreme example. 1, 2, 3, 4, 5, 6, 7 negatives. The result will be negative because 7's an odd number. Now, involving division and multiplication at the same time. Division is indicated by the fraction symbol, and we have a negative number on top, two negative numbers being multiplied on the bottom. We can just count the number of negatives in this whole expression. 1, 2, 3. We know that the answer will be negative. This will help you sort out possible incorrect answers. Look at this example. We have a positive number on top. We have 3 negative numbers being multiplied together on the bottom. That will result in an overall negative answer. In this video, we will review adding and subtracting basic fractions. The main rule that we want to remember is that in order to add or subtract fractions, the bottoms of the fractions, which we call the denominator, must be the same. Here we have an example where we have half a pizza, and we want to add it to 1/4 of a pizza or 1/4 of a pizza, but we can see that our denominators are different, so they cannot be added. We have a denominator of 2 on this fraction, and we have a denominator of 4. But the process of aligning those denominators is pretty easy. We know that we can make this 2 a 4 by multiplying by 2. So if we also multiply the top by 2, we can turn this into a fraction that we can add to 1/4. 1 times 2 would be 2, and 2 times 2 is 4. So 1/2 is the same as 2/4, and now we can add that to 1/4. We add the tops. 1 plus 2 is 3, and we don't add the bottom. We just leave the denominator alone. And that gives us an answer of 3/4. And hopefully you could see that if we combined these pictures and we move this piece over here, that would be 3/4 of a pizza. So that makes a lot of sense. Let's talk about mixed numbers a little bit. With mixed numbers, we want to add or subtract the whole number part of the fraction or the mixed number and the fractions separately and then combine. So here we've adjusted this example so that we have 1 1/2 pizza on the left, and we have 2 1/8 pizza on the right. We want to add those two together to see how much pizza we have altogether. Once again, we still need to align the denominators of these fractions before we can add them. In order to make 2 an 8, we would multiply by 4. So we'd also need to multiply the top by 4. 1 times 4 is 4. 2 times 4 is 8. So we could say that that is also 1 4/8 pizza. Makes sense because there's 1, 2, 3, 4 slices when it's divided into 8. Now we'll add the whole numbers together. 1 plus 2. We have 3 whole pizzas. 1, 2, 3. Visually, we can see that. And now we add the fractions. 4 plus 1 is 5. And we don't add the bottom. We don't add 8 and 8. We just leave that eighths. 3 5/8 of a pizza would be our answer. In this video, we're going to be talking about how to multiply and divide simple fractions. Let's take a look at the rule for multiplying fractions. It's pretty straightforward. We are going to multiply the tops of the fractions. We call those the numerators. In this case, 2 times 1. And we're going to multiply the bottoms of the fractions, the denominator, 3 times 4. And we're going to create a new fraction. So let's see how that looks in this case. We set up our new fraction, 2 times 1 on top, 3 times 4 on the bottom. Then we simplify. 2 times 1 is 2, 3 times 4 is 12. And then finally, we want to take a look at reducing that fraction if possible. 2 and 12 can both be divided by 2. 2 divided by 2 is 1. 12 divided by 2 is 6. That leaves us with 1/6 as a final answer. Let's take a look at dividing fractions. Now, we want to actually use multiplication when we divide fractions. And the way that we can do that is to flip the second fraction and then multiply instead. We call that the reciprocal when we flip it, but we can just think of it as flipping. So what we're going to do when we change this problem to multiplication is we're going to keep the 2/3 at the beginning. We're going to change division into multiplication. And then we're going to change 1/4 into 4/1. And then multiply as we normally would. So that becomes 2 times 4 on the top of our fraction and 3 times 1 on the bottom of our fraction. We simplify that and we get 8 divided by 3 or 8/3. Now we can't reduce that because there is no number that can be divided into both 8 and 3. So that would be our final answer. In this video, I will review order of operations, which is an important set of rules that are necessary to make sure that we all perform math in the same sequence. Sometimes it can be a little bit confusing about what to do first, so we need some rules to help us. So the order that we want to be looking for when we look at what's called a math expression is first do things in parentheses. Parentheses are like grouping symbols that essentially say, do this first. Exponents are next. So we want to look at any numbers that have an exponent, and we want to simplify those. Then we want to look for multiplication or division. Technically, these two are tied in the order, so we're going to perform them from left to right. If multiplication comes first when going from left to right, we'll do that first. If division comes first, we'll do that. So technically tied, as are addition and subtraction. Also do those in whichever order they appear when going from left to right. Let's take a look at some examples. So here we have 2 times 4 minus 6 divided by 2. we have three different operations: multiplication, subtraction, division. So let's try to apply our rules. We don't see any parentheses. We don't see any exponents. So we're looking for multiplication or division when going from left to right. Well, here we have multiplication. So let's do that. 2 times 4 is 8. We can rewrite our problem now. And let's apply our rules again. We don't see any multiplication anymore, but we do see division. So let's do that. 6 divided by 2 is 3. So now we have 8 minus 3. And we don't have any addition. All we have left is subtraction. 8 minus 3 is 5. So that can be confusing when you initially look at it. But if you go through it step by step and apply the rules, you will come up with the proper answer. Let's look at this one. We see we have an exponent in this. Let's look at our operations. We have multiplication, we have an exponent, we have subtraction. No parentheses. So let's take care of the exponent first. 3 to the second power, or 3 squared, is 9. So we simplify that first. 2 times 9 minus 2. We eliminated all of our exponents. We're looking for multiplication. Sure, we have multiplication here. 2 times 9 is 18 minus 2. We've eliminated all the multiplication, division. There's no addition, but there is subtraction. 18 minus 2 is 16. Now we've introduced some parentheses. Now, the interesting thing about parentheses is we still have to apply the rules inside the parentheses, but usually they're not that complicated. We can see we have multiplication going inside our parentheses. So 2 times 3 is 6, and we can drop the parenthesis then. We don't need it anymore. And then we're going to add whatever is in this parenthesis, and we can simplify that at the same time. We don't have to do these exactly one at a time. So what is 4 times 5? Well, that's just 20. And we are still now adding 3 to the second power. We've eliminated all of our parentheses, but now we have an exponent. So let's do that. 3 to the second power, we did that in the last problem, is 9. So we have 6 plus 20 plus 9. We've eliminated exponents. We don't have any multiplication. We don't have any division. We just have addition left. So 6 plus 20 plus 9 is 35. And we are done. Let's talk about how to round decimals. So the first question you might have is, why do I need to learn how to round decimals? And it's primarily because calculators will give you some really long answers with many decimals, and we need to know how to communicate those kind of answers in a meaningful way. So here's an example where we've divided 378 by 19, and we get an answer with many decimals. So let's say we want to communicate this a little bit easier without using all of those decimals. We can choose by rounding it to 0 places, or the nearest whole number, or 1 place, or 2 places, or even 3 places to the right of the decimal. And we're going to talk about how to do that. Answers to this particular problem could take the form of any of these 4 numbers with the rounding above. If we round it to the nearest whole number, we would get 20. To 1 decimal, or the 10th place, we would get 19.9. 2 decimals, or the 100th place, like money, 19.89. Or 3 decimals, the 1000th place, 19.895. We'll talk about how to do that now. In order to round effectively, we need to be aware and know how to find the decimal places. So here we have a number, 19.894738684. The whole number part is in green. That's the number 19. Then we have the decimal point. And we have that first number to the right of the decimal point. We call that the 10th place. So if you're rounding to the 10th place, there should be only one number after your decimal point. If you're rounding to the 100th place, there will be two numbers after your decimal. And the 1000th place, there will be three. Now, we could continue this, but I don't think that that's practical. These are the three that are most common. Actually, I should say four, because we might round to the 10th, 100th, or 1000th, or even the whole number. Those are the ones you're more likely to see. Now, let's talk about the rounding rules, and we'll do that in two steps. Here is a number. Step one is we need to identify the place that we are rounding to. In this case, it's the 10th place, the first number to the right of the decimal. So we locate that number. This is the number we are thinking about rounding. And then we look at the next number to the right. These are really the only numbers that we're going to use in our rounding. We can ignore all of those other numbers. So let's look at step two. Here's where we were in step one. If the number to the right is 5 or more, as it is in this case, it's number 9, that's more than 5, we're going to increase the digit that in the place we're rounding to. So this is an 8. We're going to increase that to a 9. We're going to round it up. So our answer to this would be 19.9, rounded to the 10th place. And you can see we only have one number to the right of that decimal. Let's take a look at a slightly different number. In this case, we have 19.84, a little bit different. We look to that number to the right that's in the blue rectangle. And if that number is 4 or less, we are going to leave the 8 alone. So our answer just becomes 19.8. Welcome to this video on how to order decimals. Let's get started with just a review of how we read a decimal number in maybe a different way than you're used to. We would probably all call this 10.8, but there's another way to describe this. We describe it first as the whole number part, and then we describe the decimal part a little differently. We describe it based on how many places it goes out and the decimal values that are there. In this case, we go out to the 10th place, and there's an 8 in the 10th place. So we can describe that as 10 and 8/10. Here we have another example, 0.85. Here we have no whole number part, so we might say 0. And because we want to look at this as one number, 85, and then consider how many places it goes out to. It goes out to the 100th place, 85 hundredths. Last example, 17.279. As you might have expected, now we go out to the third decimal place. That's called the thousandth place. So hopefully you're following the pattern here, 17 whole units and 279 thousandths. The reason I went through that is that it is related to the way that we sequence decimal values. So let's take a look at actually sequencing some values. Here we have 4 decimals, and we can see that the whole number part is the same, but the decimal values are all different. What I recommend in this case is to add zeros so that they all have the same number of values after the decimal point. I put a line here that indicates we are going to go out to 4 in each case. I add 2 to the first number, 1 to the second number. We don't have to add any to the third number. And we add 3 to the fourth number. Now they look more consistent, and it makes it easier to compare them. We could think of this as 108,700, 108,450, 108,799, and 108,000 even. This makes them easier to compare. Now let's order them from greatest to smallest. We look over those numbers and we look for the biggest one. And it looks to me like 108,799 is the biggest of those. You could also, because all of the whole numbers are the same, we could ignore the green part and just compare the black numbers. That will work as well. So 8,799, biggest number. We keep going. What's our next biggest number? It looks like 108,700 is the next one. Then 108,450. And then finally, 108,000 would be the smallest number.